All right, so for your enroll session, for your enroll lab session today, starting from 2:30, if you want to drop by for lab number 4, you're more than welcome to, but please go to WSC 105. There will be other lab activities going on in the other 2 rooms, just 105, please. But if you go to the wrong room, I'll guide you. And your written test number 2 will be next Wednesday, not tomorrow, but next Wednesday. I already released the guide and also example questions. So the coverage is already pretty clear from the guide. So please start going over the materials. There's also a PDF notes that's gonna help you on understanding the topic for today, which is about typecasting. I'll show you how you can find it. Go to lecture site, and then you will see under inheritance section there, you will see under required readings over here, right? There's a PDF notes. There is just going to talk about basically what I need to go over today as well, but just in more like a written form. I'll suggest also go over that as well, maybe after today's class. All right. Okay, so now you know how to find it. Any questions about the course? All right. So today, only one topic, typecasting, but we're going to dive very deep into exactly the case about typecasting. So let's do a very quick recap about what we learned from Monday. So without going too much in detail, I want to remind you guys just about several places that you definitely want to review. So number 1, so that's the rule of substitution. Whenever you got a variable assignments, you got to make sure the static type for the right-hand side must be a descendant of the static type of the left-hand side, right? That's the rule we have learned so far. This rule is so important, we're going to build on that today as well. So if the static type here is a descendant of the static type here, that means this type here can fulfill the expectation of this one here, because guaranteed descendants can always fulfill the expectation for its ancestor, right? That's something we said earlier last time. So this page here just defined about ancestor and also descendants. So just look at the inequality that we can define for expectation between ancestor and also descendants. And also we talk about, also there are certain classes that's neither ancestor nor descendants as well. We're also going to use this kind of diagram here to talk about typecasting today. Okay. And the second page, you definitely want to make sure you also go through thoroughly. It's about the rule of substitution. Was it somewhere here? Let me just see that. Let me just see. Sorry, beg your pardon. Yeah, right here. So I actually talk about, okay, this one here is about ancestor versus descendants. And this page over here is about the rule of substitution. Whenever you have a variable assignments, you want to know about the range of static types that can be for the right-hand side. So basically, right-hand side must be able to fulfill the expectation for the left-hand side. And whenever we talk about rule of substitution, it's just about compilation. Whether or not there will be a red underline in Eclipse or any IDE, basically. Okay. And then we actually also summarized Monday's lecture by this single page about polymorphism and dynamic binding. Polymorphism just means multiple dynamic types that might be possible for a single reference variable. So once I declare some reference variable, let's say here, students, static type, dynamically, on the right-hand side, it could be any of the subclasses or descendant classes that can fulfill the expectation for students. So you can see resident students and non-resident student, they can just be the subclass or descendants of students, right? So that will apply the rule. Dynamic binding simply means when you got multiple dynamic types that might be possible for a single reference variable, depending on where you're actually calling the method. For example, at this point, when I call sp1.surfWeb versus at this point when I call sp1.surfWeb, these two lines are completely identical. But which version of surfWeb is going to be called depends on, at the moment of execution, what is this dynamic type for sp1. So we tried to trace it the other day. So at this point here, sp1 dynamically is iPhone 13 Pro versus at this point, dynamic type has changed to Galaxy. So it's a different dynamic type. So different versions of the surfWeb will be called. So whenever you want to somehow see exactly dynamic binding, how that works, you have to trace the code, especially by visualize the object creation and also variable assignments. Okay? Any questions? Okay, so we're going to build on this. Question? Oh, you're fine, right? Just say hello. All right. All right, let's now go on to typecasting for today. All right. So let's start with, again, this example here, just as a motivating example. Let's understand why we will bother with typecasting. Let's now look at this example here, still using our student example. Okay, that can illustrate the point already. Let's now try to trace the line number 1 here. So we basically declare a variable called Jim, statically students, dynamically resident students. And we know that this is valid for this assignments because resident students is a descendant of students. So this variable assignment is good, it's safe. So after line number 1, what we have is we have students static type. And then we got Jim, the reference variable. It is pointing to a memory and objects. Dynamically, it is a resident students. I'll say RS, resident students. And we know that resident students should have premium rates, for example. And then we try the next 2 lines. We say that given that dynamically, Jim is really pointing to a resident student's objects, which should support premium rates. What I want to do is, can I actually create a resident student's variable RS? Let RS point to the same object as Jim. And after the variable assignment, my intended use is to call RS that set premium rate to be 1.5. And I want to set this one to be 1.5. That's my intention. Because Jim dynamically is really pointing to a resident student object. So I really want to assign Jim to another reference variable RS and set a premium rate using that variable. All right, that's my intention. Now, question for you. Is this code going to run? Or is it going to compile? Anybody would like to give a try? That's very important. Daniel, go ahead.
I don't think it's going to compile.
You don't think? Okay, how come? Which line? Line number 2 or 3?
2.
Line number 2, you don't think that will compile. How come?
Because Jim is a type student, and it's not a descendant of the...
Yeah, okay, good. That's correct. All right. The way I kind of explain is not wrong conceptually because Jim is really pointing to resident students. I should be able to change his premium rate. I should be able to. All right. However, the rule is a rule. This is not going to compile. Because Jim's static type, which is students, is not descendants of right here. Students is not a descendant of resident student. As simple as that. All right? So follow so far? We are just applying the rule of substitution. Now we seem to have a dilemma. As far as the rule of substitution is concerned, this is not going to compile because Jim statically cannot fulfill the resident students. However, if you look at the visualization here, Jim is really pointing to here. So this really addresses some limitation for the compiler that we would like to somehow work around a little bit. So this is the scenario where we really want to use maybe something to override somehow the rule that's kind of set by the substitution. When I say override, not exactly, but we want to work around. How about that? Okay. So this example here is very important. You want to understand why it wouldn't compile and understand a scenario where dynamically it's really something we would like to do, but we're just one step away from the workaround. Okay? So now to really kind of solve this one here, right, you can see the compiler is not being very smart to really keep track about dynamically what Jim is pointing to. If the compiler can somehow know Jim is really dynamically pointing to RS, then we should be able to allow this particular variable assignments, right? Sounds sensible. So now I'm going to give everybody in section B A+ challenge. Okay, let me describe the challenge. You can take until the last day of class or even the last day of the exam period to try to somehow work on this challenge. If you can actually make it work, I'll give you A+, unconditionally. No question asked, as long as you can convince me that you got something working. Doesn't need to be exactly working, but as long as you're on the right direction. I'll give you A+. Okay, here's a challenge. I want you to write a program. The program can be written in any language of your choice. Can be in Java, can be in C, can be in Python, can be in C++, whatever language you like. And the program should work in the following way. The program will take two input. It's going to take some Java file. And the Java file could look something like this. For example, the Java file, let's say myclass.java. That one there has a main method. And then we kind of statically declare S to be here. And then at some point at the last line, I reassign S to be some resident students. So I know that the very last dynamic type for S happens to be resident students, right? According to this program here. I want you to take some arbitrary program as an input. Arbitrary. And this program here is just one example. The second input is going to be the name of a variable. For example, it could be just S. And your program is going to tell me something very simple. Tell me at the end of the execution for this input program here, which is here, only one class. You don't need to handle multiple classes, just one class with the main method. You want to tell me what's the last dynamic type for S. In this particular example, the very last dynamic type for S should be resident students. That's an example run. If you can write a program that kind of heads to the right direction for this one here, A+ for the course. You don't even need to worry about your result for the exam or programming test. Seriously, all right? Okay, does it sound doable to you? If that was doable, why would I ask you to do that, right? Okay, so here's the thing, important. If you could actually write a program that's going to solve this problem here, what you really deserve is not really an A+ in my class or in any other class. You deserve a Nobel Prize. All right? So this is a known problem that's known to be undecidable. So because you guys are in CS, so I'm pretty sure either you're taking EECS 2001 or maybe later, you'll learn about something called undecidable problem. Computers are very powerful. They can solve many problems. On the other hand, there are many more problems you just cannot solve by computer. And this kind of problem is one kind. You just cannot solve, right? I wouldn't dive too much into detail. That would be subject to some very abstract proof, which we don't have to go to. I want to give you some intuition, okay? So this is known to be an undecidable problem, which means no computer or no program can ever implement this, all right? So just to know it, don't try, don't waste your time. It's not possible, all right? So what's really what's the undecidable nature over here? Whenever you want to write a program which is going to take another program and infer about its dynamic behavior, it's undecidable. You just cannot. Right? Not feasible to write a program that infers the dynamic or runtime behavior of another program. Okay, I'll just maybe hand wave a little bit. Why is this undecidable? Okay, very intuitively, because the program here can be arbitrary. So the best you can do is to somehow simulate the running each line by line and see how the variables are being changed. But what if somewhere in the middle, what if it contains some while loop or for loop and the loop never terminates? In that case, your simulation will never halt, will never terminate. In that case, you cannot even give me an output. All right? So that's in general like a so-called halting problem, which you guys will talk about, right, in your EECS 2001. All right? That's all I want to say. So the message to take away from this one here is really for your knowledge. Okay, may not terminates. A simple scenario like this somehow seems to illustrate that the compiler is being very limited. It simply cannot even know Jim is permanently pointing to resident students objects and allow this particular substitution. It's really, the limitation is something much general. There's no compiler in IDE which is going to tell you At this point, it's really pointing to dynamically something. It's just not possible to infer. Even if you can infer in this case right here, but if the program gets more complicated, it just cannot be, right? So it's kind of inconsistent if he ever tries to do that. Right, so given that, we know that we can now really rely on Eclipse compiler to really do that for us. Now, what can we do as a programmer? That's the thing we want to talk about for typecasting. What we can do is, if we are so sure at that point of execution that we can do that, like a set premium rate for Jim, in that way we can try to create an alias of that objects. And that alias is going to have the static type that's going to allow that expectation. Does that kind of sound familiar? We can just talk about something along the line, right? When we talk about object equality, right? When we talk about typecasting, right? So this is now typecasting to be discussed in thorough detail, all right? Let's now move on to the workaround that we can do as a programmer. But before we even talk about typecasting, anything you want to do manually, you always have some risk. If you want to do typecasting, if you know exactly what you're doing, and also you know the rule, and also you know the consequence, you'll be good, as long as you're experienced enough and disciplined enough. However, as we'll see, if you are simply just don't know what you're doing and typecast whatever type you like, you might make things compile. However, you might run into something called typecast exception, which we're going to talk about today as well. Whenever we talk about typecasting, there are two dimensions you want to talk about. Dimension number one, does the typecast compile? Number one. Number two, if the typecast compiles, when it gets executed at a runtime, is it exception-free? Class cast exception. So these are the two things we're going to focus on today thoroughly. All right? Let's now just revisit the syntax about typecast, which we kind of walk you through back in the object equality lecture. But it doesn't hurt to brush up. Okay? Let's now look at this line over here and analyze it. So our starting point is we got Jin, statically students, right? Just remind yourself the students over here is the static type. And the resident students right here, which is valid, is dynamic type, right here. And we know that pretty well since we traced the code. Now, what we want to do is we want to create an alias of this particular objects, and then let that alias have a particular static type that will allow us to call the things we want. How do we do that? Well, it's exactly typecasting, right? So what I want you to look at is, first of all, let's start with what we know. We got Jim over here. So this is the object we start with, Jim, and also Jim, right here. And also remind yourself, for Jim over here, it has the static type students. Okay? In this case, we know that Jim dynamically is really pointing to resident students. So why don't we try to cast that? Okay, so we're going to create another expression here. So think about right here. Okay, I'm going to put in orange. Okay, sorry. Orange. There we go. This one here. Cool. Okay, this one here is a cast expression. Typecast expression. What that does is it's going to create an alias right here. However, that alias has no name. Well, that alias here is just a copy of the address of Jim, but has no name. Anonymous. Anonymous objects created by the cast. And that one there has a static type resident students. So here you can think about the RS over here. It is the static type. Or at the same time, it's also the cast type. So now as far as the right-hand side of the variable assignments, we have an expression of static type resident students. That's what we're doing. And then, can we now do this variable assignments? Now we can do it, because the right-hand side statically is a resident students, which is a descendant class of the resident students. That's why we can do it. And what do we do what do we do exactly here? RS. So here we say RS is going to be assigned to the same place as the typecast expression right here. Okay? Right here. And RS has a static type RS. And right now we can say RS dot set premium rates 1.5. This one will compile. All right? And just to remind you, before, if we say gym dot set premium rates 1.5, that one there is not going to compile because statically gym is students. And the students does not have the expectation of set premium rate. It's in the child class, right? That's the kind of exercise we did earlier. Okay, let me recap and then we'll take questions. The workaround that we are trying to do to somehow help the compiler a bit is to say, assuming that we really know what we're doing, okay? We're basically saying gym statically is pointing, statically is a student. Dynamically is pointing to a resident student at this point. And we're just creating anonymous object or alias right here by using typecast. This type here, you can call that the static type for the expression for cast. We can talk about, or you can say that as a cast type, either way. This expression here has the static type corresponding to the cast type, resident students. So once we have done that, the right-hand side for the substitution has resident students, which can fulfill the expectation of the left-hand side, which is what we said on Monday. So that's why this variable assignment here is going to compile. So the variable RS over here is just going to point to the same object here. So now we can use this RS using the expectation of resident students. Okay, it's about syntax and runtime consequence of the typecast. Notice that for typecast, you are not really modifying the static type for gym. That one stays to be student, but we're just creating something new. All right? Question? Daniel?
Is it though possible to change the type of gym in some way? Or?
You mean change the static type for gym?
Yeah,
No. Static type, again, the rule is simple. For static type, once you declare, you cannot change it. There's never, ever a way for you to change it. Yeah. Dynamic type, yes, you can change it whenever you do reassignments. All right, let's now leave this. Of course, keep that in mind. We're going to need it. One more page just to talk a little bit more about syntax. And then we're going to talk about important stuff about compilable versus exception-free cast. Okay. So here, just another example here. Okay, let's see this. Okay, let's do visualization just once more. Okay. Let's consider these three lines over here. Okay. So what we have is, I'm going to draw right here. So here we have a static type, smartphone. Okay. So smartphone is right here. Okay, so that's a static type, the one we want to cast eventually. And then we have the dynamic type, iPhone 13 Pro. All right, iPhone 13 Pro. So this line here is valid, is safe because iPhone 13 Pro is the descendant class of smartphone. That one is good. All right. So what we have is we got a phone pointing to a iPhone 13 Pro objects. iPhone 13 Pro objects. Like that. Okay? And then let's now do some cast. We want to cast a phone right here. Dynamically, we know it's really iPhone 13 Pro. Let's cast to that particular type. It's always safe to cast one variable, some object to its dynamic type. But we'll talk more about this, okay, for now. We just cast to the same type that corresponds to the dynamic type. So cast to here. What that does is it creates an alias right here. So this one here is going to create an alias right here. That alias has the type corresponding to the cast type, which is iPhone 13 Pro. So that one is iPhone 13 Pro, right there. And then on the left-hand side, we want to have a variable here. Okay, can we do this particular substitution, right? We can, because here the cast type is iPhone 13 Pro right here. Okay, I'll just highlight it. It's happened to be just the same as the dynamic type right here. We're basically asking this cast expression has iPhone 13 Pro. Can it fulfill iOS? Yes, you can, because iPhone 13 Pro is a descendant class of iOS. So we can do that, all right? So that one there is really the ultimate thing that we actually want, right? This is the ultimate thing. So that one there is, has a variable. So let's say for Hyang. Okay, that one there will be here. All right, so now if you compare, the original variable a phone has the static type smartphone, but now the new variable here has iOS. So they're different. All right, that's because we can do typecast. And finally, let's have this line here. When we say use this variable here for Hyang, the static type is iOS. Does iOS support FaceTime? It does, right here. So that will compile. Okay? So this one here will actually work because the static type of for Hyang is iOS, which supports the FaceTime. So we are basically just repeating just about what the consequence is whenever you want to do a typecast, right? Just make sure you understand about the different pointers that we are creating right here. Okay? Question? Any part you want me to clarify, repeat? Okay, things will just get more and more intense today. Okay, please make sure you slow me down. Okay, next one. And when you do typecast, you can either choose this flavor here. You can assign the typecast expression into some variable and then use that variable onwards. That's one way. That one is okay. I think nothing wrong with that. But sometimes if you find that you just want to use that typecast once only, you don't necessarily have to store that typecast into another variable separately. You don't have to. So what you can do is so-called anonymous cast. Basically a cast without a name. Okay? So what we do is here, you can see that. So notice that we are doing some typecast right here. So we are casting a phone into iPhone 13 Pro. That's the same expression as right here, the same. And then we simply don't really assign that to another variable. We simply put parentheses around over here to say, do this typecast first, and then use that typecast, which is an alias, to call the method that we want. So this one here will also work equally. It's just that you don't really have a name for the cast. And just remind you, if you look at the left-hand side for the dot, so the context object is a typecast with static type corresponding to the cast type, iPhone 13 Pro. All right, so that's also something to remind you. Okay, right here. Is the parenthesis really necessary? That's the next question, right? So here we got parenthesis. We try to say, we are kind of force the evaluation here. I want to say do typecast and then do method call. Okay, it turns out the parenthesis will be necessary. Okay, let's say we try to do still the typecast right here, but I don't have the parenthesis around, right? You can see I put dot here and then afterwards. All right. So this one here, you got to understand exactly what that one's saying. It's saying something completely different. So if you, this is something about precedence, about the order of evaluation. When you don't really have the parentheses here, that means you want to evaluate the method call first and then cast that method call result into this particular type. But that one is not going to work. Okay? So let's now make some notes over here. So this one here will be as if. We said you want to say a phone dot FaceTime. Do that first. And then you want to cast that into iPhone 13 Pro. It will be as if. So now if you look at this expression over here, it's not going to compile because all this one got to be evaluated first. If you look at a phone, statically, smartphone. The static type is smartphone. Does smartphone support FaceTime? No, it doesn't, right? so it's not going to compile. The main point is when you want to really use anonymous cast, you got to make sure you put a parenthesis around to really force the order of evaluation. If you don't have that, you're going to run into compilation error. I would encourage you to actually try this out, maybe in your lab number 4. You might find some occasion you can use the typecast conveniently. Whether you want to use a name cast or anonymous cast in the programming test or the lab is completely up to you, right? But you got to know how to write both, maybe for the test and for the exam. Question? All good? Okay. Let's now move on and talk about compilable cast. Okay. Let's say we're given this hierarchy here, and then I have certain, okay, let's see. Let's start with this, okay? The best way to really explain is to use one example, okay? Let's now consider this one here, okay? Here. We have my phone right here. And then we static type for my phone is Android. Let's now identify where it is in the hierarchy. Android, right here, is here. Okay? So this is the static type of my phone. And notice that we talk about compilable cast. That means we are not worried about any runtime behavior. We just want things to compile. Let's worry about that dimension first. Once we know under what circumstances can a variable compile by casting it to a certain type, let's do that first, and then we'll worry about runtime behavior. Okay? So let me say that explicitly. To consider compilable cast, disregard dynamic type. We just don't need to worry about it. I can even cross it out for now. Okay. Now there are two types of casts you can do. Either you can cast upwards to one of the ancestors, or you can cast downwards to one of your descendants. Intuitively, if you go up to your ancestor should have less expectation. If you cast to one of your descendants, any descendant should have more expectation, right? As we said last time about ancestor versus descendants, right? Let's now see, okay? So now, I have two options here. I can either try to cast upwards. If I go upwards over here, in that way, I'm basically trying to cast into a ancestor. Okay? So if I go this particular direction, it's called upward casting. Upward cast. And if I do that, I'm essentially saying I want to somehow reduce the expectation of the reference variable. That's what I'm trying to do. Why would you want to do that? Maybe you want to restrict the access of certain attributes to that particular variable. Maybe you don't really want any external user to really get access to premium rates. In that case, you can upcast from resident students to students, in which case you don't have the premium rate anymore. Okay? Upward cast is basically reducing expectation. And then it might be for example, access control. Okay? But it's important to realize it's actually reducing. But I'll do the table together with you. Let me just write down the principle first. Okay, reducing expectation. Or you can actually downward cast. Okay? If you do downcast, you can basically downward cast relative to the static type over here, to any of the descendants. Okay? So I can also go right here. I can go, okay, let me use a different color. How about that? I can downward cast to here. I can go that here. I can also go all the way down, basically any of the ancestor. I can go this way. Okay? If I can also downward cast to any of my descendants. That's called downward cast. So in some way, I am increasing expectation. Okay, let's now try to look at this example here. Let's look at this line here. Okay, this one here. You can see my phone. Okay, let me just highlight it. Okay, my phone is right here. And then I'm trying to do my phone cast to one type. My phone cast to another type, right? These two, okay? If I look at smartphone, apparently I'm basically casting from Android to smartphone, right? Upward cast. And also, if I look at Galaxy S21 Plus, I'm casting really from the static type. Okay, Galaxy S21 Plus. I'm casting from here down to over here, right? That's a downward cast. I'm showing you both. All right. And of course, each one of them is just an expression. And this expression here is smartphone. Smartphone can fulfill smartphone. So that's why SP can be assigned, right? And also, this expression here has Galaxy S21 Plus as a static type. I can also assign into Galaxy S21 Plus, just the same. Right? A class is the descendants of itself. Let's now draw this table here. Okay? Let's now do a little bit more precise comparison. Let's look at the original my phone right here. Okay? My phone here statically is Android. Okay? Android is definitely going to have expectation of dial, surf web, and also Skype. Right? That's kind of the exercise we did earlier. Right? So let's now do that one. Okay? So I'm going to have my phone is going to be dial, surf web, and also Skype. Okay? Everything else will not be allowed. It's not part of the expectation for my phone. All right, right here. And let's see the result for upward casting. All right, let me also remind again. So this one here is an upward cast. And we have the result for SP, statically smartphone. SP now has smartphone as a static type, which should be expected for dial and surf web only. So that means we can only check this one here and this one here. On the other hand, everything else will not be expected anymore. Right? You can see I'm just comparing the SP here with its static type, smartphone. That's why I can only have dial and surf web. So what used to be available for my phone right here for Skype, after the upward cast, I reduce the expectation. So when I use the SP here, I cannot do sp.skype anymore. It's not allowed. Okay? So here, if I say sp.skype, it's not going to be allowed. Because statically, SP is already smartphone. Okay? Hello? Can you please get off your headset, please? I appreciate that. Thank you. Okay? And then the third one. So let's say GA. Okay? So that one, there's a result for downward cast. Right here. So this one here is downward cast. Okay. So once we have done the downward cast, so now GA has a static type Galaxy S21 Plus. And if you look at it right here, right, this class over here, that one, if you work your way up, you guys get side sync, Skype, surf web, and also dial. Right? These are all the expectations you have. So what we have is right here. We got dial, surf web, Skype, and side sync. Everything else will be disallowed right here. All right. Let me recap, and then I can take question. When we talk about whether or not a typecast should compile, we only worry about static type. right? We don't really talk about dynamic type just yet, only static type. And when you talk about static type, you kind of fix that one location in the hierarchy. As soon as I have my phone fixed Android right here. So now I have so many choices to really do typecast. I can either try to cast to one of the ancestor. In this case, only one choice, right? You don't normally cast to itself. Of course you can, but you don't really do that. Also, I can also downcast to any of the descendant classes as well, right here. Okay? You might be wondering, how about these classes? They are neither ancestor nor descendants. If you try to do them, you're going to get right into compilation error. I'll get to it a little bit later. Okay? So when you do upward cast, after that, this particular cast expression has the ancestor as a static type. So that means it has less expectation. On the other hand, when you do downward cast into one of the descendant classes, that cast expression has a static type, the descendants, which has more expectation. So whenever you do upward or downward cast, you just play with the expectation. You're creating more like a copy of addresses of different static type. But you are not really modifying the MyPhone static type. The MyPhone has always got a static type, Android. You never change it. Okay? Guys, question? Before we take a break. Please.
I just have one question. So we're keeping the dynamic type different from static type to keep the class open to like the child class? Or
I wouldn't think in that direction. I would say, okay, in general, static type and dynamic type, they don't need to be the same. They will be valid as long as the dynamic type is a descendant of the static type, like what we said, back on Monday. So here you can say this is one type, this is another type. Doesn't matter. They don't need to be the same. But when you consider whether the cast should be compilable, you only worry about static type. You don't worry about dynamic type just yet. Okay. All right. So why don't we take a short break and take attendance, and then we'll talk about runtime behavior for compilable cast. All right. So quick recap from what we talked about before the break. So the first dimension you want to talk about typecast is about compilation. So whenever you talk about whether a cast should really compile, you only look at a static type for that particular variable you're trying to cast into. Okay? So upwards or downwards is always with respect to static type. You can disregard temporarily about dynamic type. Okay? You can either try to cast the static type upwards, reducing expectation, or downwards, increasing expectation. Right? So that's really the main lesson from there. Let's now look at something interesting. Okay? So now, second dimension. Being able to do a cast and also pass the test for the compiler doesn't really mean you're not going to run into trouble for runtime. For example, if you simply write your program manipulating array, having the program compile doesn't really mean you wouldn't run into array index out of bound exception. Right? And also having your method call being compilable in your lab doesn't really mean you wouldn't run into null pointer exception. Similar idea. Being able to compile your typecast doesn't really mean you wouldn't run into some trouble, like we're going to say right now. You got to be very careful when you do typecast. So for today, and also for your written test number 2 next week, you just have to know exactly how you can run into compilation or runtime error for typecast. And then next Monday, which will be not part of the written test 2, I will talk about this operator you can actually use to really always safeguard your typecast. That's for next Monday, which is not covering the test. All right. Let's now talk about this example here. All right. Let's now be careful about each line. Okay. So what we do is, and here, I think we can visualize. Okay. Line number 1, right here. So what we have is, let me start with right here. Line number 1. We have a gym variable pointing to some non-resident students objects dynamically. Okay? So you can think about the static type for gym is students. Okay, let's put it right here. Dynamic type right now is non-resident students. Good. And then the second line here is a cast. Now, let's see if you guys are able to answer already. Try. Is line number 2 going to compile a typecast? Daniel?
I think it's going to compile
How come?
because
Okay, or put it another way, are we doing an upward cast or downward cast?
We're doing a
Downward cast, very good, okay? Whenever you want to ask yourself whether a cast should compile, just ask, is it upward or downward? If there's neither, then it doesn't compile. So let's now look at where we are right now. So here we got students is the static type. And dynamic type is non-resident student. Okay, for now, okay? And then we have a cast type, resident students. Okay, so we now got all the classes covered, right? So let me write it down here. Student is the static type. And resident student is a cast type. As far as the cast is concerned, it's a downward cast. So we are okay. Okay? Let's also write it down as well. So this one here, compile, because it is a downward cast. And then later on, so after the cast, what do we have? We got RS. Think about the cast itself. We basically create some alias over here, and that one there has the resident students, right? And then we also got RS, which is a variable. Statically, it is resident students. All right, so far so good. And just to remind you as well, we know that NRS, non-resident student, has discount rate. Maybe up to this point, you already can see what's going on here. Something is going wrongly at the runtime, right? Because now, if I try rs.set premium rates, rs, do I have premium rate to set? I don't, right? So this is the kind of situation you have to watch out, okay? I will explain a bit further. This kind of situation means you have a typecast which gives you some alias or the variable of certain static type. However, you're using that static type on the dynamic type NRS over here, which is not going to fulfill its expectation. In this case, you're going to run into something called class cast exception. Okay, I'll go slowly here, right? If you look at here, right here, okay, let's look at this line here, the final line. This line here is problematic. Because dynamic type NRS does not support the premium rates. It only got discount rate. Because line number 3 is problematic, so the typecast itself should not be even allowed in the first place. That's why there's an exception there called class cast exception. All right? Let's now look at the cast itself. So now, if you want to decide whether or not you got class cast exception, you will have to look at dynamic type. Okay, you will have to, right? Before the break, we talked about whether or not the cast will compile. You only look at static type. But now, if you want to see if you run into class cast exception, you have to consider dynamic type. Okay, they kind of work together. Okay, let's see exactly. Let's now look at this line specifically. Okay, and let's now be very clear for the very first example, and we'll do one more, and then we'll summarize. Okay, this one here, number 1 compiles because downward cast. However, number 2, at the runtime, if you execute that typecast, it's going to trigger something called class cast exception at runtime. Class cast exception. So later on, I might just say CCE, for class cast exception, it's just easier for me to write quickly. All right, but why? So here, you got to think about dynamically, NRS cannot really fulfill the expectation of RS, which is statically resident students. You can see the resident student come from right here. Okay? Or you can think about that one there correspond to the cast type. So this is really the type to look at. Okay? Let me write it down and then I'll recap. Because dynamic type of Jim which is NRS, cannot fulfill the expectation of the cast type, which is resident students. Okay, that's one way to say that. Okay, let me say that's A. A here is the more intuitive way to really see. So you got to make sure the dynamic type right here can fulfill the cast type right here. Oh, let me just say, dynamic type can really fulfill the cast type. How do you check that? In order to fulfill the cast type, the dynamic type will have to be a descendant class of the cast type, right? So we talk about A here. Let's also say B, which is equivalent. Okay, I'm going to put B here. Okay. Dynamic type of Jim, which is non-resident students, is not a descendant of the cast type, which is resident students. Okay, let's recap, and then I'll take questions. Okay, and we'll do one more example. Okay. Whenever you see a line of typecast, there are two issues here. Number one, does it compile? To really decide that, you only have to look at the static type for the variable you're casting and also the cast type and look at their relationship. Are you doing a downward casting or upward casting? If that's either way, then it compiles. Finish, dimension one. Dimension two, given that the typecast compiles, are we going to run into class cast exception? It really boils down into asking the following question. Does the dynamic type of the variable you're trying to cast into, does that dynamic type fulfill the expectation of the type you're trying to cast into? In this case, Jim dynamically is pointing to non-resident students, which is right here. And you're trying to cast that variable into resident students right here so that you can use like a premium rate later. But in this case, we're going to get class cast exception because non-resident students dynamically just cannot fulfill resident students. Non-resident student is not a descendant class of resident students. So you wouldn't pass that runtime check. All right, question? Daniel.
I know we can't redeclare the dynamic type once it's created.
Okay, let me correct you precisely. You wouldn't say you redeclare the dynamic type. You don't really declare. So dynamic type will change as you actually do the variable reassignments, right? So, sorry, say it again. What's your question?
Sorry, I lost track.
Maybe come back later. Yeah, whenever that comes back to you. All right, let's do one more example quickly. Let's do it in a slightly more efficient way, okay? And let's see what's going on. All right, another one right here, okay? So now let's be more efficient here. Let's pretend this is like a test question. How can you decide quickly, okay? First of all, I got smartphone. That is the static type right here. Okay, I'm going to write down exactly the static type. And that's the static type of a phone right here. Dynamically is a Galaxy S21 Plus right here. So this variable assignment here is good because this is a descending class of that. Good. Line number one, no problem. Okay. Line number two is about typecast. Can I cast a phone, which is a smartphone, to iPhone 13 Pro? Compilation-wise, I can because it's a downward cast. So this one here is a cast type. And this one here is a dynamic type. So I can do it. Okay? So if I do the downward casting here, and now the question is whether or not I'm going to run into a typecast exception, class cast exception, is to see whether or not the dynamic type can fulfill the cast type. It cannot, because Galaxy S21 Plus is not a descendant class of that. So it's not going to pass that check. Okay, compiles, but class cast exception, because dynamic type Galaxy S21 Plus not descendants of the cast type iPhone 13 Pro. All right? So similar pattern here, right? So whenever you want to do the full analysis of particular line of typecast about dimension 1, compilation, dimension 2, any risk of class cast exception, you have to look at all the 3 types together. All right? So that'll be the way to really solve the question more efficiently. All right? And 2 exercises over here for you, 1 here, and also 1 here, right? So you can see the solution also on the slides, okay? Any questions? All right, let's now generalize this to see the compilation and also class cast exception issue here. Let's put it in a simple single hierarchy and think about exactly how we can categorize the different classes. Okay, let's still use our smartphone hierarchy here. Okay, so there are 4 categories we're gonna study. First of all, dimension 1, whether or not the cast should really compile or not. Given that it compiles, are we gonna run into class cast exception or not, right? So these are the 2 dimensions. Let's start with dimension number 1, okay? Let's say for this particular given example, we got my phone, Android, right? So what I will do is, I'm actually going to Android. So this is a static type. At this point, I only want to know about compilation. I don't need to consider dynamic type just yet. So this is the static type of my phone. So now, what classes can I cast my phone into? Either upward or downward, right? So I'm going to use green. If I go upward, it could be smartphone. Technically, I can also cast to itself. Not very useful, but I can do it. Or I can cast into any of the descendants. So all these are the compilable classes for cast. Okay, so think about all these. Are compilable casts, okay, with respect to the static type. And the remaining part here, right here. So these are the classes of non-compilables, right? Let me just be consistent with what I put there. iOS, iPhone SE, iPhone 13 Pro. So these are neither ancestor nor descendants of the static type Android. In that case, if you try to cast my phone into any one of those classes, it's not going to compile. You're going to run into compilation error. Okay? So all these will be non-compilable cast. Non-compilable casts. So we now have dealt with dimension number 1. Dimension number 2. Given that those for those compilable casts, which ones is going to run into class cast exception? So now we talk about dynamic behavior. In this case, we're going to bring our dynamic type into play. All right. So for that one there, we're going to look at. We're going to look at dynamic type, Samsung. Okay. So Samsung here. Let's now do right here. You can see I only bring the dynamic type into consideration in the dimension 2. So this is the dynamic type. All right? So now we want to know which classes, while compilable, is going to give us class cast exception. So thinking this way, if we are trying to cast my phone, which is dynamically a Samsung, to any type that expects more than Samsung. In that way, we're going to run into class cast exception. All right? Well, put it another way, ask the question, what can this dynamic type fulfill? Basically, any class can fulfill the expectation for itself, also any of its ancestor, because ancestor is guaranteed to have less than or equal to expectation compared with the class itself, right? So that means right now we're going to say the dynamic type and its ancestor. So these are the ancestor of dynamic type. In this case, there's no class cast exception, because if I try to cast my phone right here to any of the ancestor classes along the dynamic type, guarantee dynamic type can fulfill the expectation for its own ancestor. Okay? So this is important for you to see. All right? On the other hand, if you look at the final category, anything that is not the ancestor for the dynamic type. So these are not ancestor of dynamic type. That means dynamic type cannot fulfill their expectation. In which case, if you try to cast into any of these, you're going to run into class cast exception, because Samsung here just cannot fulfill the expectation. All right? Okay, 4 categories. All right? All right, question? I only got one more example I want to go through. That one takes about 10 minutes, so we do have some time to clarify before we move on. Yeah, go ahead.
I'm a bit confused about class cast exception.
Sure.
You said that if we do add fashion to any of the child classes, even in Samsung, it's not going to work for their method?
Put it this way. We know that this is dynamic type, Samsung, right? So we know that all the ancestor for Samsung, including Samsung itself, guarantee, okay, put it this way, okay? So ancestor of Samsung has less than or equal to the expectation of Samsung. Because we know that when we go upwards, you just get less and less expectation. So if I only try to cast the variable into a type that's actually happen to be the ancestor for dynamic type, we know that it can handle it. For example, if the dynamic type is actually resident students, in that way, if I cast that into resident students or cast that up to students, I know I can handle. On the other hand, if I cast while the dynamic type is actually resident students, if I cast into non-resident students, it's not ancestor. In that case, I cannot handle. Right? Mm-hmm. Okay, question? It's definitely something you want to go over maybe before Monday. I can definitely do a recap again. But I definitely want to struggle through about this example here. Okay, one more example, and then we're done for today. One more. And if you can grab a piece of paper, you can do some exercise right now. We can make it more interactive. Okay. So here, I want to show you one exercise from the slides, but we can do it in phases. Okay. Yeah, you can grab a piece of paper if you want to do it. Okay, right here. Okay, so now, can you, phase number 1, can you somehow draw the inheritance diagram based on these decorations? Take it 1 minute to draw that. All right, that's step number 1. And I think for your practice test for written test 2 next week, I gave you something more complicated, but let's do some simple ones. Okay, shouldn't take you more than 1 minute. Shouldn't. Yeah, take your time. I think we do have some time before the end of today. So just remember, every extends keyword corresponds to an arrow pointing upwards. And we only got 4 classes here. All right. Okay, I'll take one more moment, and then we'll show you the answer. Well, you can picture in your mind exactly how you might look like, either way. All right, for those of you who are done, Something like this, right? Let's double check. Class A, A. B extends A. B extends A. C extends B. C extends B. Beg your pardon. Sorry about that. Thank you. Yeah, let's do it again. Class A, Class A. B extends A. B extends A. C extends B. C extends B. D extends A right here. All right? Okay, good. So now we have the hierarchy for us to work with. Okay? So now let's now consider two lines again. Is this line going to compile? You're basically asking, is C a descendant of B? Yes. Okay, good. So that one is good. Compile. Now, is this going to compile? Take some time. Take some time. We talk about compilation, meaning that you can do either upward cast or downward cast. Here we are casting B, statically is B, to D. Are we doing upward or downward? Neither. Doesn't compile. All right, follow? Okay. First of all, let's agree, this one here, not surprisingly, not compile. Because D, the cast type, is neither ancestor nor descendants of the static type of B, which is B. Okay, that's a full reason. Doesn't compile. However, I can make a compile. All right? To really make a compile, I'm going to play some, just play with the compiler really. Okay? Let me write in this way. Okay, I'm going to rewrite this line. Rather than this, I'm going to say, okay, declare D, D. And then I'm going to do, first of all, I'm going to cast the B to A. And then I want to do another cast. Do you see what I'm doing here? Does it compile? There are two casts. So what we do is, first of all, do this cast first. We got parentheses. We're casting from B up to A. So now this cast expression has static type A. Can I cast A to D? Yeah, down to D. So it will compile. I do upward cast and then downward cast. This pattern here tells you a lot, teaches you a lot. That means in Java or any OOP, you can cast from any type to any other type. I can cast from vaccine to channel between your lab 2 and lab 4. I can do that. How would I do that though? Basically, I need to find some class that's at the very top of the hierarchy, upcast all the way to there. And from there, I can downcast to anything I like. So in this case, how do I cast from vaccine to channel? Exactly. I can cast any class to objects, and then downcast from object to any other class I like. But this is only for compilation. We still got to pay the price at some point. All right? Let's now look at what's happening here. Okay? Compilation-wise, this one here is an upward cast. And this one here is a downward cast. So conclusion is compiles. And then overall, this expression here has the static type corresponding to the cast type, which is D. I can definitely do the assignments. Compiles. But what about the runtime? Somehow I make it compile. Does that mean I also get rid of the class cast exception? There's no magic like that, really. You still got to pay the price at the runtime. All right? So now let's see exactly what's going to happen. All right? Let me copy this line here, just about the cast. Okay? When I actually put cast B to A and then further cast to D. Now, I got two typecast, right? Upward and downward. Which cast is going to give me the class cast exception? The upward cast or the downward cast? Because whichever happened first is going to disrupt the flow, right? As soon as the exception occurs. Yeah, go ahead. Downward. Okay, I agree. That's the right answer. But why don't we go over the detail? Okay, that's correct. Okay, let's be careful here. Okay. At this point, we know that B here dynamically is C. Now, when we try to cast the first one, when we try to cast B to A, are we going to have class cast exception? We ask the following question. Can C fulfill the expectation of A? Can it? Yeah, because C is a descending class of A. Yes. So we wouldn't have any class cast exception at this point. So that cast is safe. All right. And then we try to do the second cast. Dynamic type is still the object that's sitting there. It never changes dynamic type. We haven't reassigned anything. Right? So now for the second one. Right here, the second one. And we're asking a similar question. Now, can the dynamic type still remain the same, right? Can the dynamic type C fulfill cast type D? Can C fulfill D? No, because D is not an ancestor for C, right? Let's now write it down. No, because the cast type D is not an ancestor of dynamic type C. Okay, so that means we got class cast exception in this typecast. Okay. This example here is also very important. That tells you, for you as a programmer, you got some power. You can basically cast any type to any other type as you wish. However, you want to make sure at the runtime, you don't really have to run into class cast exception, which is in general very hard to debug. All right. All right, let me just take 1 or 2 minutes. I think we can finish earlier today if you don't have questions. Right? Give me 1 minute, I'll recap. Okay. So that will be the end of the coverage for your written test 2. Again, that's also set in the guide, which will be slide number 67. All right, let me recap. Give me 1 minute, and then I'll let you go. Okay. So it's very important. Let's see what we have seen today. Right. So we started with about the motivating scenario about typecast, and then we talk about, in general, it's undecidable to really have the compiler tracking the dynamic type for you. Just not possible. So we have the workaround called typecast. And you should really understand the visualization for the typecast. And then we talk about upward versus downward casting for compilable cast. And then we talk about if your cast compiles, you might run into the class cast exception if the dynamic type of your variable being cast cannot fulfill the cast type. That's a critical question you want to keep in mind. Okay? And then also revisit this diagram over here about the 4 different categories. And then also think about this example here, about how you can trick the compiler, but still got to pay the price at the runtime. Question? I'll take one question, please. Okay.
Just one question. So when we typecast D from, when we typecast D to D, can we still use the method in D, or can we not use it?
Okay, let's say this. So let's say this compiles.
Yeah.
So when you say D dot, what expectation do I have? It's according to the static type for D, which is all the methods in D. But that's only at the compilation. But you don't really even get to those methods because the typecast would have failed already. So you don't even get there at the runtime. All right, thank you so much. And then I'll see you next week.